Hello friends, you are welcome in my channel SKS Learn and today we are going to understand the decision tree analysis. And it's a very big term, decision tree analysis, and I believe before that we have to understand some technical terms. Otherwise, the coder will start codings and you will get confused what is that. You can copy that codes, but you cannot link this with the your case study or the findings or the conclusions. So I thought before understanding decision tree analysis, we should understand some technical terms. And if you see, I have listed all the technical terms which you should know before plotting any model or any matrix. It's a long list, guys. It's like a confusion matrix, grid search, CV, train and test split, decision tree classifier, parameters, pairing, scatter plot, alpha, why we change alpha, why, what is the conclusion for the train accuracy, and what is the conclusion for the test accuracy. So I believe we should understand that technical terms first, and then we will move to decision tree model building. I have already prepared that file for you, but we are not going to discuss this today. Okay, so I personally believe that you should be aware with these technical terms first, then only you can understand the codes and its result. Otherwise, it's all waste if you are just copying the codes, pasting it somewhere else, and you actually don't know what you are going to do, right? First term says create search CV. You most probably you will use that, but you don't know what is that. Confusion matrix. You have used this in a many models. You have used this in linear regression. You have used this in logistic regression and many models, but you don't know what is this. Why this is connected with your findings and your result? How this is affecting your accuracy? Scatter model, it's a scatter plot, train accuracy, train and split data, parameters defines, alpha accuracy, prediction, pairing, decision tree classifier. So this is not practically possible to understand all the terms in one video. So let's focus today on confusion matrix only. What is this actually? I just try to convey a simple message. I'm just explaining confusion matrix and connecting this confusion matrix with your case study, whatever you have done in your past in Python, and what is the result we found in the Python, and what is the findings on the basis of this confusion matrix. So connect. I'm just trying to connect this theoretical part with the practical part. Okay. As you know, guys, very well, confusion matrix is a simple diagram where we fit our data as per the yes or no. Yes, whatever it's maybe for the actual data, no, whatever it's from the prediction data. If I say this model, so let's consume this is my prediction data on the column wise, and my actual data is on row wise. If I say, let's connect this with your practical case which you have done for the bank loan eligibility. If you remember, we have done this in a logistic regression previous video. Okay, so let's connect with this. I have predicted some value and that model, so my results should come in this column wise, and whatever actual result this comes should be row wise. So here I'm just taking the total value of 165. My prediction result means bank loan. As per my prediction, bank loan should be given to 50 people, and my on my actual data also this is matching. Yes, I'm okay. Should not be given to 50%, 50 numbers. Because we are just taking an example of total number of 165, right? It's a true negative here. If my prediction is say, okay, give this loan to 10 people, but my actual data is saying that no, don't give this. So here we are, our thoughts are not matching. Prediction data is not matching with the actual data. So this is called type 1 error, where my prediction is saying yes, but my actual is saying no. So guys, this is type 1 error. Remember, where both data are not matching and my prediction is yes. This is type 1 error. Now let's move to next one. My prediction is saying no. don't give loan to these 5 people. But my actual data say, please give this because we have a good history. So here also, my thoughts is not matching with my prediction. My actual is not matching with my prediction, but my prediction is saying no. Actually saying yes. So this is type 2 error, guys. Remember. Let's move to next. My prediction is saying yes. Okay, give this data, this loan to 100 people. And my actual data is also saying, okay, give this loan to 100 people. So we both are matching here. So this is called true positive. Okay. The one more thing, guys. Actual result, whatever I have given. Now see, my actual is 50 when I'm saying no, when I'm saying no. Right? It's a total is 60. My actual is for yes is 5 plus 100. It's a 105. So total of my actual 165 should match with the total 165. Now move to prediction same. If my all total of the prediction no, it's a 5 and 50, it's a 55. And prediction yes, 10, 100, it's a 110. So the total of prediction also should come to no, 165. Right. Prediction or actual cannot go more beyond the total data, 165. Right. Hope you understand these things here. Now let's move to the some formula, and it's very easy. Like see, first formula is accuracy. Accuracy formula is very simple. We have to take all the true value, whatever matching with prediction and actual. So these cells which are not highlighted yellow, right? Because we both are matching. Prediction is saying no, actually saying no. Okay, 50 numbers. Prediction is saying yes, actually saying yes, 100 number. So 100 plus 50, true, positive, true, negative. And it's the what is the percentage of that whatever we are matching. It's a simple formula. We are saying we are trying to get the total percentage of the total numbers, right? My total numbers which are matching and which means actual and prediction are matching, it's a 150, and my total numbers 165. So 150 out of 165, it's a 91 percentage, guys. So 91 percentage actual data is matching with the prediction data. It means it's the accuracy of a matching. That's why we are saying this accuracy percentage. Got it? Now let's move to error rate. As I defined error, we have two types of error. When our prediction data is not matching with the actual data. My prediction is saying yes, actually is saying no. My actual is saying yes, prediction is saying no. Right? If I count this data, there are two formulas, guys. Either I have total accuracy numbers. Remember, right? I have total accuracy number 91%. If I deduct this total accuracy out of 100 percentage, then 0.9% will be my answer. It's a simple formula, right? Right. If you want to go in a technical terms, it's the false positive, false negative. It's the same thing, guys. These all false sales are making total. I have added two sales, right? And less minus, I will get these two sales. False positive, false negative divided by total. Or type 1 error negative, type 1 error positive divided by total. Same formula, it's a technical terms are only changing, right? Result will same 0.09 percentage are my error rate, where my actual data is not matching with the prediction data. Next formula is precision. Precision is very simple formula and recall. Both are simple. In both formula, we have to check the yes data only. Where yes means yes is an opportunity for the company where my company is actually interested. Try to understand this precision and recall. Actually, my company is interested here. If you see the end result of this all findings models, the bank want to see who is my customer actually, right? My company's opportunity is lying in the yes only. So see, so I'm more interested in yes. As per my model, I'm getting yes. As per my prediction, there's a yes 100. As per my actual, see, yes, formula will remain same. I have to see the percentage of the total positive by the predictive yes or actual yes. If I say my prediction is 100, okay, this is 100 both as per prediction, as per actual, and we are matching here, guys. 100 should be 100, right? It's a positive and eligible for the loan. These 100 people. Okay, now let's see. This 100 people is a what percentage of the total prediction data and what percentage of the total actual data. Total means my total years of prediction is 110, and out of 110, my 100 is matching with the actual. So what percentage? See, 100 divided by prediction years, 110, 64% we are matching here. Same for the recall. 100 is my prediction where we are matching. My actual is 105. 95 percentage we are matching here. Let's check this data again. Oh, it's a 90 percentage. Bad. 91 percentage we are matching for the precision, and recall is matching with the 95 percentage. Right now, let's connect this confusion matrix with our one of our practical case study which we have done. Okay, if you guys remember, we have done one case study, right? That case study is that one. Yes, we have done that case study for the bank same, which we are discussing. So I'm not showing the total of the codings here. Let's take only the piece of that code which we have used for the confusion matrix. If you remember, we have done this confusion matrix here, right? Confusion matrix and by test, and we got this result 5, 6, 8, 7, 6, 6, 2, 6, 8, 5, 1. So let's put the same result in this 5, 6, 8, 7, 6, 6, 2, 68, 5, 1. And guys, remember this model which we have already discussed in the column K and L. I'm just trying to link this with this practical model. If I see the total of the my prediction total, it's the total should be match 6072 6072. This is first terms. Actual should match with the prediction, right? If I see the accuracy of the model, to guys remember the sales which are true positive means my prediction is matching with the actual, which are not uh, blue highlighted 5, 6, 8, 7, 51, right? So now we have to see the percentage of this matching with our total data. So see the formula. I'm just placing 5, 6, 8, 7 plus 51. It's the 5738 divided by total data. Total maybe anything 6072. 6072 both are same. So my model is matching 9449 percentage, right? If you see the answer, if you got whatever you got for the Python codings is the same 94493. You can see everything is matching here. This is the same concept. If I try to find out the error rate of this uh, model bank data, so my error rate means my accuracy data minus my 100% of the data, of course. So it's a 0.05 percentage of the error match. Error means where we are not matching with the prediction and actual. All the blue highlighted cells, which are a type 1 error, type 2 error. This is a percentage of the total. So it's a very low 0.05 error. If I see the precision, precision is very simple. If so see where we are matching positively means the numbers 51, where we are where company is more you can see interested to know this 51 is a yes as for the prediction as for the actual. What is the total numbers of the prediction and actual and percentage of this? You can see it's a very easy 51 divided by the 117. It's a total yes from the prediction. So my opportunity is here 43 percentage as per the prediction, and as per the recall it's the 51. It's a total of about 319 years. It's only 15 percentage as per the actual. So this is something which we can link guys with our findings, confusion metrics, and after that we can create our accuracy and we can check our model, reframe, whatever we have to do. But the first things we need to understand why we are making this confusion matrix in our model and what is the end result of that matrix. I believe, guys, you love that all the things whatever I try to do explain here. In next video, let's see one by one these all technical terms. Then only we will be able to uh, start our decision tree only. Otherwise, uh, there is no logic to do decision tree. Just copy and paste the codings and here and there, and we don't know whatever we are doing. Right? We should understand these things. Next video, let's see these technical terms now. Thank you so much. Thanks, guys. Bye. Take care. See you in the next video.